Some probability problems require you to identify 3 events. In this case, we have 3 events, event A, event B, and event C. Their common region is that one there, that is where A and B and C intersect. So that is the region A intersection B intersection C. Then that region there is where A and B, just A and B intersect, no C is there. The outcomes in that region are found only in A and in B. And similarly, the outcomes here are found only in B and in C. And the outcomes here are found only in A and in C. And so the outcomes there are in A only, and those outcomes there are in B only and nowhere else. And these outcomes here are in C only. And obviously there are some outcomes outside. Those are not in A and not in B and not in C. They are found anywhere outside A, B, and C. This is kind of the picture that we will be using to solve similar problems. Obviously, there is another way of naming these regions. So instead of saying A and B and C, you could say A intersection B intersection C, and so on. Let's look at this example here. A survey was done among 80 learners. So clearly there are 80 learners altogether. So if you're going to draw a Venn diagram, they will ask us to draw a Venn diagram. But this is a problem, a word problem. This problem can be easily solved by drawing a Venn diagram. And the first thing you need to identify in a problem like this are the events that are there. So right now we are told there are 80 learners. So this is our sample space, and the number of learners in the sample space is equal to 80. That is what you write. That is how we write number of outcomes in S. So there is 80 of them altogether. But if you read your question, it says 52 learners like rugby. So there is an event for rugby there. 42 learners like volleyball, that is V, and 5 learners like chess. So these 3 here tell us there are 3 sets. So now we need to draw those 3 sets inside our sample space. Let's call this one R for rugby, that one V for volleyball, and that is C there for chess. So we are given that 52 learners like rugby, 42 learners like volleyball, 5 learners like chess only. It says they like chess only, so we need to read everything very carefully. Now, 14 learners like rugby and volleyball, but not chess. 12 learners like rugby and chess, but not volleyball. 15 learners like volleyball and chess, but not rugby. X learners like all 3 types of sport. 3 learners did not like any sport. The best thing to do for me is to read through my questions or read through my situation and particularly check whether I'm given the number of players or the number of learners who like all 3 sports. So it says X like all 3. So I know that I need to put X in here. So I'm putting in the number of learners who like that particular sport. So X like all of the 3. What else is obvious to put? Remember, altogether we have 80 learners in this question. Right, it says 3 did not like any sport. So 3 did not like any sport. So clearly 3 must come somewhere outside R, V, and C. So we're done with that one as well. Then this here tells us that 15 learners like volleyball and chess, but not rugby. So volleyball and chess, but not rugby. And that there should be the region. The 15 should be there because we need 15 people that like volleyball and chess, but they do not like rugby. Remember, X like volleyball and chess and rugby, but 15 like only volleyball and chess without rugby. Right, let's go up to 12 there. It says 12 learners like rugby and chess. So 12 learners like rugby and chess, but not volleyball. So rugby and chess, but not volleyball. So 12 should be here. So these 12 like rugby and chess, but not volleyball. Right. Then it says 14 learners like rugby and volleyball, but not chess. So we have our 14 there. Okay. Now we move on to those three statements there. We are given that 5 learners like chess only. 5 learners like chess only. So that's chess only, so 5 will come there. And we are told 42 learners like volleyball. Now, volleyball is everything inside V. Already inside V, we have 15 and 14 and X. But we should have a total of 42. So we need now to take 42 and subtract 14 and subtract 15 and also subtract X. And we know that this is 13 minus X. So we have 13 minus X here. Then up here it says 52 learners like rugby. So 52 like rugby. So everything inside R must add up to 52. Already we have 12, 14, and X inside R. So we need to take 52 and subtract the 12 that we see there, and subtract the 14 as well, and also subtract the X. So we end up with 26 minus X. Okay, 26 minus X. So question 1 is asking us to draw a Venn diagram to represent that information. And that is the Venn diagram that we drew there. I just copied it here as well. Then question 2 says, show that X is equal to 18. The idea here is when we add all these numbers inside our set S, they should amount to 80 because the number of outcomes in S is equal to 80. So all we need to do is to take all the numbers that are in there, all of them, add them up together and put that equal to 80. So 26 minus X plus 14 plus 13 minus X, right, plus 12 plus X plus 15 plus 5 plus 3 must give us 80. If you solve this equation, you should get X is equal to 8, which is what they want there. The next question says, how many learners like rugby only? So rugby only should be that set there. That is where rugby only is. That event represents rugby only. So rugby only is 26 minus X. But we know now that X is equal to 8. So that should be 26 minus 8, which will give us 18. Then the last question, calculate the probability that a learner chosen randomly likes at least 2 different types of sport. Now that term at least, so at least 2 means 2 or more. So how many learners like 2 or more? We know that we have 80 learners altogether here, but out of the 80, how many of them like 2 or more sports? So for 2 or more sports, this is what you need to look at. These 12 people here like 2 sports, rugby and chess. These 15 here like 2, which is volleyball and chess. And the 14 there like 2, which is rugby and volleyball. And the X here, we now know that X is equal to 8. So we know X is equal to 8. So those 8 also like all 3. So remember, at least 2 means 2 or more. So in this case, to answer this question, all we need to do is to take that 12 and take the 8 and take the 14 and the 15 and add them up together. Right, that should give us 49. But the question is asking for the probability that a learner chosen at random will like at least 2 spots. So to answer the question, the probability that a learner chosen at random likes at least 2 will be the 49 that we got there divided by 80.